the recording. Sumedh Dhyan has joined. Yeah, thank you, Sumedh, for agreeing to give a session on calculus. You may start now.
Yes, thank you.
The session is being recorded.
Okay, sir, one second. Yes. So I hope you can see the screen.
Yes.
So today we are going to discuss calculus. So people here, can anyone just say what calculus is basically? Uh, okay. Can anyone say what calculus is? Please.
I know that there are two. This one is differentiation and other is integration. Integration is
Okay.
trying to combine many elements up to infinity. Differentiation is trying
Uh-huh.
to divide a particular thing up to infinity.
Okay. So calculus basically is study of continuity, continuous changes, ranges, etc. Okay. And in calculus, we deal mainly with functions. We deal with functions. These functions. Yeah, and these functions may be continuous. We are trying to find, we're trying to operate. Well, basically, calculus is used to operate on a function to do different sort of operations. Now, what is a function basically? Anyone? And Dhyan, it is nice to see you here. Today, I think the session is more of a hands-on session. So it would be nice if you have a book with your book in your hand. So we are going to understand calculus in a very practical and in a very depth manner. So having a book would be very handy. So, anyways, what is a function? Can anyone say what function is?
Function is a predefined, defined instructions.
Okay. Function is and there is some output, and function is one second. Yeah. And okay, one second. Just a second, sorry. Yeah. And function is used to define that relation. We can say it like that. So yeah. So basically, function will have two components. Sorry, three components. First is the input. Input one, two, three, something. Then some rules. Okay. There are some rules that map an input to an output, basically. Okay. Now, for example, so by looking into this, can you say the relation here involved? The rule that I used to map an input to an output. So basically, I did something x square. So whatever input is coming, I'm squaring that input. So this is the rule. So this is one type of a function. This is what function is basically. I hope it is clear.
Yeah.
Yeah. And now, whatever the input it is here, we call it as domain. And we call this as a range. Okay. I hope you are clear with domain and range. And there is one rule that you have to always remember. Input is always mapped to one output. Is that clear?
Yes.
Yeah. Now let us, with this understanding, let us try a few examples then. Uh, okay. Let us try to solve few. Let us try to find some domain and ranges, so that we understand it in much more depth. Now, I will have a. I'll give it a question. One second. So I have f of x that is equal to. Now, can you say tell me the domain and range of this function?
One and
Can you
one.
try?
One and one minus four to two. Sorry,
Huh.
plus or minus
Uh,
two.
so okay. So basically, let's talk about domain first. What do you think that input I can pass into x? You know that if you pass a negative number to the x, negative any negative number, what will happen? It will become complex. Okay, it should not
Yeah,
happen. We need it to be lying in the real domain. So basically, the domain would be including zero. Zero can be x value, right? X can be zero. Square root of zero is zero
yes,
to infinity, right? And
yes.
what would be its range? Domain is what are the input that I can give for x. What would be its range then?
Negative, positive.
Uh, I don't think square root ever gives out negative value. Uh,
No, no, no.
Square root is
And
always
positive
non-negative,
value.
right?
Yeah, positive value.
So yeah, the range would be also infinity basically. I hope you got it.
Yeah.
Huh. So now what is this unique brackets here? You can see one is square and one is a normal parenthesis. What would be the difference here? So this is called as these brackets. Whenever you write x and y in this bracket, generally it says we do not include the x and y value. For example, if I say there is 1, 2, 3, 4, 5, if I want to represent 1 to 5, if I want to represent 2 to 3, I can represent it like this. This means it does not include 1 after 1 before 5. If I wanted to include entire 1 to 5, I would use the square brackets. Square bracket says including the number. Okay, I hope it is clear.
Okay. Yeah, yeah.
Okay, yeah. Now let us slowly move further. Uh, Now let us try to understand types of functions here. There are 6 types of functions. So let us go one by one. First is one to one. One to one. So basically, what is one to one?
One domain, one range.
Ha, correct. So every the domain elements are mapped to exactly one element in the range. Basically, that is one to one. Then there is we have one to one. We have on to. First, I will write what all the things that we have. Then we have bijective. We have many to one. We have constant functions. We have identity functions. Okay. Now,
Okay.
what is onto function now? So onto function, we can say has uh, there is a topic called as codomain basically. So this is domain, this is codomain, this is range. Okay, one,
Okay.
two, three. Let us now try. Now I will define codomain for the function x square. Okay, f of x equal to x square. So now, can you see there are a lot of other values inside the codomain, but
Yes.
only few items are in the range. But in onto function, all the extra elements will not be there. For example, all these extra elements will not be there. It will be mapped to exactly uh, the range. That is basically onto function. So range would be equal to codomain. Okay.
Okay.
I hope it is clear. Now,
Yeah.
what is the next one? That's something called bijective. What do you mean by bijective? Any function that is both one to one and on to is called as bijective function. Okay.
Oh, okay.
Then we have inverse function. Okay. Yeah, we have many to one function. What do you mean by many to one function? Many to one function, multiple input will map to same output. So for example, I have 1, I have minus 1. 1 maps to 1. This also maps to 1 in x square. Right?
Yes.
The rule of function is one element must map to exactly one element. It does not say two elements can match the same element. So do not get confused with the rules. So one item must match to one element. The rule is satisfied for a function to happen. This is an additional element that also matches to the same element. So it is completely fair. Such type of functions are called as many to one functions. Then there is inverse function. We will come to inverse later on. Then there is identity function, constant and identity function. So constant function is something like f of x equal to 5. For any value of x, it will remain constant. Such are called as constant function. And identity function is f of x equal to x. So any value of x, you will get back the same value. Is it clear?
Yes.
Now let us understand inverse function. So what do you mean by inverse? So basically inverse function says given a function f which has a domain D and domain D to range R, there exists a function f inverse such that its range will become its domain and its domain will become its range. So inverse, ulta of the function. Is it clear? So if there
Yeah.
exists f of x equal to y, then there will be f inverse y that will be equal to x basically. Okay.
Yes.
Now let us try to solve few problems on the inverse. Inverse is a very important topic in uh, calculus, basically. So now I will give you a problem. Uh, Sir, you can also try it out. So let us try to find inverse of this function. How do you? Okay, basic. First, one example I can solve for you guys. But after that, let us try one example where you
What,
guys pick
what
up
is
the
this?
pen and solve it.
X cube plus 4, is it?
Yeah, x cube plus 4 basically. So how would you calculate inverse? So there is simple trick. F of x equal to x square x cube plus 4. You write x as it is. Instead of x cube, replace it with y cube plus 4. Then you just find value of y. X minus 4 cube root. That's equal to y. Okay. Did
Yes.
you understand what I did here?
Yeah.
So basically, I replaced x and y, and then I tried to solve, and I got this function. Now, interesting thing is, if I do f inverse of f of x, that is what I will do. I will apply f of x. What is f of x? F of x is x cube plus 4. Okay. So now if I do cube root x cube plus 4 minus 4, I will get back x. Okay, that is a very that is the interesting bit here. I hope it is clear.
Yes.
Okay, yes. Now let us move further and let us try one more sum. Uh, I would like to give you a problem. So you have to find inverse of uh, what was the previous sum I gave? X cube plus 4. Let us do something simpler then. 3x minus 4. Can you try to find inverse of 3x minus 4?
Okay. X plus 4 by 3 equal to
Huh.
y.
So you just write y equal to 3x minus 4, y plus 4 by 3 equal to x. Now, whenever if I find inverse of this, I'll get back my x value. Okay, that shows that inverse exists basically. I hope it is clear.
Yeah.
Okay, now now let us move further. Now let us try to understand few important topics. Okay, before that, let us try to understand composite function. Do you have any idea of composite function?
No.
Okay, composite function. Imagine there exists f of x, a function, and g of x. Okay, now composite function is basically mixture of this f of g of x. Okay, or g of f
Yeah,
of
yeah.
x. That basically means f g of x. So first you have to add, I mean, mixture of both. One good example for this would be, uh, what can we solve for this? Okay, imagine f of x equal to x square and g of x is equal to x plus 1. So now we are doing f of g of x basically, right? How can I do
Yes.
this? First, g of x. First, I need to, instead of, let me write g of x. So first step, f, what is g of x? X plus 1. Okay. Now, what is a function of
Yeah.
f? F is x square. So basically, I have to do x plus 1 whole square. That would be my f of g of x basically. Is that clear?
Yeah. Clear.
And remember one thing, f of g will not be equal to g of f. At least in general, it will not be true. There may be edge cases, but generally, f of g is not equal to g of f. Is that
Okay.
clear?
Yeah.
Okay. Now, let us try to solve one few examples in this topic. Then, uh, what problem can give? Okay, one second. I have to find a problem for you. Then, one second. So, okay, now I'll give you the problem. F of g of x you have to find. F of x is 3x minus 2. G of x is square root 5 plus x, square root 5 plus 4x. I hope the question is clear. F of x is 3x minus 2. G of x is square root 5 plus 4x. Can you solve this? You have to find,
Trying.
yeah, you have to find f of g, okay?
Okay. I don't know whether it is correct or wrong.
Mhm.
3 3 root 3 into root 5 plus 4x minus 2.
Yeah, it's absolutely correct. So we understood the composite function. So to recap, what all we learned? We learned what is domain. We learned what is range. We learned what is codomain. We learned types of functions, inverse, and we learned composite, right?
Yeah.
Okay. Now let us move further. Now these are some basic concepts basically. Now we are going to touch upon important topics. The important topic include limits, continuity, uh, determinant, and integration. We will understand why do you use these things and how did they originate basically. Okay.
Okay.
So what is limit according to you? What is the limits and why do we need limits?
Um, it's a boundary.
Okay, let us understand the need of limit by an example then, and with that only I will explain you the definition of limits. Imagine there exists a function f of x. Okay, f of x equal to 1 by x minus 1 x square minus 1. Okay, there is such a function exists. Imagine like that. Now, what happens when x is equal to 1? What will happen to this function?
0. 0 by 0.
Huh? 0 by 0. What is 0 by 0 basically? Undefined.
Depend.
Okay, 0 by 0 is basically undefined. You
Yes.
know this any number divided by 0 is like infinity. We can say it like that, right?
Yeah, yeah.
Yeah. So now, but in this scenario, can I can if I use 0.99999, very small number, okay? Will it
Mm.
that also turn to be undefined?
No.
If instead of 1, so yeah, basically that time what happens, this will never become 0, it will be some small value, right?
Yes.
Or if I use 1.1111, very small number, that time also it will not lead to 0.
Yes, it is 0
So
point
so
0.
we can say, imagine there exists a straight line, only at this part it is undefined. The function is undefined at a very small point. Rest of the time we can have some value for it, right?
Yeah.
So limit is used to tackle such situation. So limit is used to limit that function. It helps us to helps us to solve this undefined situation, overcome this situation. That's why limit came into existence, basically. Okay.
Okay. Okay.
In limits there are two types. One is left and other is right. And if this both becomes equal, then only we say ordinal limit, we say it like that. So that only we say with the limit exists. Okay. Now, what
Okay.
is continuity? We'll come back to this topic later on. What is continuity now? I just mentioned about continuous nature. So you see, you can see it is undefined here. So it is not continuous at this point. So continuity helps us to check this itself. Okay. Is
Yeah.
it clear what
Yes,
continuity is?
yes.
Now let's come to determinant. What is determinant basically? Sorry, derivatives. What do you mean by derivatives?
Different. Differentiate.
Uh, there are better ways to say what derivatives are. Derivatives helps us to in in a if a graph is given, derivatives are used to check rate of change of y with respect to x basically. Okay,
Yeah.
delta y by delta x. How will y change with the small change in x? That is derivatives. I
Yes.
hope it is clear.
Yeah, yeah.
Is it clear?
Yes, it's clear.
Okay. Now, now let us understand why limit comes to play, and how does limit helps us to find derivatives. Do you know this derivative of x square? Let's go back to the x square example. Do you know derivative of x square?
2x.
Uh-huh. Now let us try to analyze how did we get 2x. Till now, whatever we did in our early days, we used to by heart this formula, right?
Oh, yeah.
Do you know the origin? How did we go from x square to x for derivatives? That today we'll see basically now. So now as I said, what is derivative? Delta x, delta y by delta x, or dy by dx, right?
Yeah.
So now I said small change of x with respect to small change of y. So how can I represent it in a form of function for x square? Can I represent it in a form of function? Basically, f x plus dx. Dx is the small change that we did. Okay,
Oh,
minus
okay.
old x. You can see if I subtract, for example, I better example would be I have 1, I 1 plus 2 minus 1. What will I get?
2.
2 back. So in the I came to know what value I added back.
Yes.
Are you able to understand what I'm doing here?
Yeah, 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 yeah. I
Huh.
can, I can.
So this is what I'm doing here, where I am subtracting new value with the old value, so that I can get the difference. What was the difference? Dx as
Mm-hmm.
it is
Yes, yes.
same function. Instead of writing dy like this, I'm writing dy like this. Okay, I
Yeah.
hope it is clear. Now,
Yeah, it's clear.
now let us try to limit this function. Okay. Now let us apply limits
Okay.
here. So limit dx tends to 0. When dx becomes 0, this becomes not defined, right?
Yes. Yes.
So why it will become not defined? When dx becomes 0, f of x minus f of x is 0, dx is 0. So it is not defined. I hope it is clear. That's why we are
Yeah.
using limits here now, in order to prevent such situation. Limit f of x plus dx minus f of x whole by dx. Now I'm applying limit. Would you like to try? Would you like to try applying limit, or should I proceed further? Should I try it out myself?
You try.
Yeah, I will do it, because I think we did not touch upon how to solve limit basically till now. So, anyways, f of x plus dx minus f of x d. So I am applying limit. In limit, what we do is we try to simplify this equation. Okay, now for us the equation is x square, right? For us we have
Yeah.
f of x is x square. Now let us try to do this. So f of x plus, that becomes f of x plus dx whole square minus instead of x square. Am I right?
Yes.
One second. One second. I think I'll write
Yes,
it
yes.
better. So when I apply x square, what will it become? X plus dx whole square minus x square by dx. Basically, instead of the writing the function as it is, I am writing the function's definition. Instead of f of x, I am writing its exact whatever it was given in the question. So I got it in this form. Okay. Can I simplify this? Can I expand? Can I try to solve this? Yes, I can. So what is x plus dx square? That is basically x square plus 2x dx plus dx square minus x square whole by dx. I'm just expanding this dx plus a plus b whole square into a square plus 2ab plus b square. I hope it is clear.
Yeah, it's clear.
Okay. Now what happens? Now something unique happens. X square cancels, x square cancels. Okay.
Yes.
Uh, now we are left with, what are we left with? Now we are left with
2x dx
2x
plus
dx plus dx square by dx.
dx.
Okay, now if I apply limit, okay, before applying limit, let us split this 2x dx by dx plus dx square by dx. I can do this, right? Absolutely, I can do this. Right?
Yes. Yeah, yeah.
Yeah, I just, instead it was common, I just split it out. Okay, now dx cancels, dx cancels. The remaining is 2x plus dx. And I still have the limit. Don't forget the limit. X tends to 0. This is what I have. Now if I apply 0 here, 2x, x tends to dx tends to 0, right? Now apply, if I apply 0, what value do I get here now?
2x.
So I get 2x. I hope it is clear. So it was limit was defined for dx basically. So dx becomes 0. So I get 2x. And basically this is what the formula was doing. For x square, 2x. X to the power n, we always say n x to the power n minus 1. So this is what basically it was doing behind the back. It was also using limits, but it was made easy for us. We just were able to mug up the formula and we were able to solve the sum. I hope you are able to understand how limit is used here.
Yeah, yes, yes.
Yes. Okay, there is some error I am getting. 1 second. Interesting, isn't it?
Yeah, it's
How we are able to link subjects. Now, topics basically. Now, what is integration? Integration, integrals. What is integrals? That's a very formal definition of integrals. Can you try?
integrals.
So integral
No.
is used to find area or area under the curve. Okay.
Oh, okay.
Okay. Now imagine there exists a function like this. Now if I want to find area of this, integral will help me to find the area. Okay.
Yes, yes.
It is. I hope it is clear. So
Yeah, it's
imagine.
clear.
I think we have learned about basic integrals when we were in UC 10th and all. So what would be this answer to this question? Can you try? Do you know? First we apply some
Integral.
formula. X dx means it will be x square by 2, right?
Yeah, x square by 2.
For 0 to 5. What would be the value for 0 to 5 here? We just apply it and we get 12.5
Minus.
basically, right?
Yeah.
Yeah, we have learned this in our we have learned this. We have mug up the formula. Now again, here also limits comes into play. Okay, you might
Okay.
ask how. You can see how beautifully they are intertwined, how they are linked. So now, what operation did I do here? I found the area under the curve of x dx, right?
Yes.
So there is this function f of x equal to x, that is like a straight line, and I found the area using integration. Now let us use limits here. How can I use limits here? Imagine
Hmm.
I have same curve and and it is defined for 1 to 5. 1 to 5, right? This is x, this is y. Am I right? Now, instead of calculating, how will you calculate the area if you do not know about integration? You would calculate area like this.
Yeah.
Basically, you will draw triangle. Rectangle will find the area. Every rectangle will try to find the area, right?
Yes.
Okay. This is one rectangle, and this is the final rectangle. Okay. Now, now let us first do this manually once. Let us see if we can find the area. So, what is the formula for rectangle? Area of rectangle? Length into breadth, right?
Yes. Yes.
Yeah. Now, what is the length here?
4, 5.
Length is always 1 unit, right? 1 to 2, all it's 1 unit basically. So L
Yes.
will be always 1, and the breadth will be it will be 1 here, it will be, you can see this is height basically. 1, 2, 3, 4, 5, right?
Yeah.
If you can see, it moves like this. I hope it is clear why I'm
Yeah.
saying the height is that value. So now
Yeah. Yeah.
we can say area of rectangle is, we can say 1 plus 2 plus 3 plus the area under the curve is. I hope you understood. Area of this, area of this, area of this, area of this. All if I sum together, I will get the area of the total curve, right?
Yes. I understood.
So instead of multiplying 1 every time, I'm just directly writing the value. I get 15 units. 15. I got
Yes.
area 15 here, but in integration, I got what did I get? 12.5. Does that mean my integration is wrong? Hmm?
No. No.
What did we miss here? One unique thing we missed.
That.
In
Yeah.
integration, we always have something called as plus constant. That plus constant is used to handle the error. Okay,
Yeah.
handle this error variation. Okay,
Okay.
just keep this in mind. Coming
Hmm.
back to our topic, you can see every time we calculated the area of rectangle, we also included these small triangles, right?
Yes.
You have to remove this. I don't
Yeah. We
think,
have.
because it is an additional burden. So now let us try to remove this. How do I remove this? How can I come to know what is the area of this? So if you look carefully, the height of this triangle is also one side is also 1. Always it is 1. It is just jumping, right? And
Yes.
what is this value? This is also 1. Am I right?
Yeah. Yes.
All these are 1. And so now, now what is the formula for area of rectangle?
Then height
Ah,
into
ah, come on. Half
what?
into area of the
Height.
rectangle.
Height into
Height
breadth.
into base, basically.
Yeah.
So now, in our question, what is the height? What is the base? Both are 1, right?
Yes. Both
So I
height.
can I can half I will write as common. For every triangle, h into b is 1. 1 plus 1 plus 1 plus 1 plus 1. Because why? Why did I write 1 4 times? We have 5 squares. 1, 2, 3, 4, 5. Right?
Yes.
5 rectangles we have, hence I wrote 5. That becomes 5 by 2, that is 2.5. This is the total area of all the triangles that I have. What was the total area of all the rectangles? 15
Yes.
minus
15.
total area of square
2.5.
triangles, that would lead to 12.5. This is what we found using the integration,
Yeah.
right?
Yes. Yes.
Okay, this was straightforward straight line, but sometimes we also get curve. Now, how do I solve curve? If I draw a rectangle like this, you can see I'm drawing rectangles. You can see some of these areas are getting missed. So in order to constitute for that, we are used to use constant. But one additional thing we can do is we can use limits, and we can reduce the size of this rectangle. Instead of big rectangles, very small rectangles. I hope it is clear. More number
Yeah.
of rectangles that we form, lesser the constant value we need. This is basically
Yes.
what integration is. I hope you understood what integrals are.
Yeah. Yeah. I understood.
Yeah. Now, uh, now let us try to learn some other things. 1 second. Would you like to solve some sums regarding this, or we move further?
Yeah. We
Okay.
can. We can go further.
So we will learn two topics, additional two topics. One is L'Hospital's rule. Have you heard this?
What?
L'Hopital rule.
No.
So now, whenever we do limit operations if it is in the form of 0 by 0 or infinity by infinity. We use L'Hopital rule to solve that equation basically. I hope you are clear.
Yeah.
Okay, now I'll show you by an example where we are using this. Okay,
Okay.
let us try to solve for sin x. Okay, now
Okay.
I am given a question sin x by x. Now and the limit is limit x tends to 0. Okay, now
Yeah.
now what happens if I directly apply x equal to 0? What
0
is
by
sin
0.
0? Sin 0
0.
is x is 0. So it is, can I now I'll apply L'Hopital rule because I know if to apply this rule it has to be in this form. So it exists in this form. Now what I can do is it says that I can find uh, I can find the sorry, derivative of this function and I can solve this, right? That's what L'Hopital rule says. So now let us find determinant of sin x. Do you know the formula?
Yeah.
Can you say uh, what would be the determinant of sin x then?
Cos x
Ah, cos x.
minus
And what would be here? Determinant of x, that would lead to 1, right?
1. Yes.
Now if I apply 0, cos 0, what is cos 0? 1 basically.
1.
So you can see this from undefined we were able to get some value for that limit. So this is why we use L'Hopital rule. Okay.
Okay. Yeah. Understood.
Now with this understanding, let us do one thing. Let us try to solve a few sums. If you have any doubt, you can ask. Next 15 minutes, I would like to dedicate to solving few sums and solving any doubts that you guys that may come here. Okay.
Okay.
I think I covered all the topics that I wanted to cover in this session.
Yeah. Okay.
So let us try to solve few sums then. It would be nice if you have a book or a book and pen. So I'll give you out the questions.
Yeah.
Okay, can you solve this for me? Or should I do this sum and next sum onwards we will try ourselves?
Okay.
Okay, we will solve this. Okay, first of all, before applying the rule, you have to see whether we can apply the rule or not. So if I x is equal to 0, if I do it, what will happen here? Down it will become 0 anyways. X 0 by power 0 is 0 only. But here, ln equal to 1. Ln becomes 1. Here also ln becomes 1. Do you know what ln equal to 1 is? It is 0.
0.
So 0 minus 0, again, it will become not defined.
And
Infinity, basically. So we can apply the rule. So when I apply the rule, what will happen? Ln, what is the formula? You know I hope you know. D of dx would be 1 by x, basically. So here, what will happen? Here it will be 1 by 1 plus 2x and it is a chain rule here. So you have to solve for this also. What would be 2x? It will give me 2, right?
yeah.
Minus 2 by 2 as it is 1 plus x and then whole is divided by x square becomes 2x. Now one second. So can you see the entire equation now? So
Yes.
now what happens if I apply limit? What happens? Any idea?
Uh,
It will again be, again it will be in the 0 by 0 form, right?
yeah, 0 by 0.
So electrical says we can continue this. We can do we can find the determinant once again. So we can do it do the same operation again and again. So I'll do it one more time now then. So if I do one more time, what will I get? If I do it one more time, I will get it is as it is. So I get square minus 4 pi 1 plus 2x whole square plus, I hope you came to know what I did here. I just applied the formula. That's it. Okay.
Yeah, yes.
Okay. If it is hard to understand, I will do it once here. So basically,
No, no, no.
no, right? You understood it. What I did here.
Yeah,
So I got this. Now if I apply again 0, what will happen here? If I apply 0, I get minus 4 plus 2 by 2. That is equal to minus 1 basically. So this time I'm not getting not defined, I'm getting the actual value. So we applied L'Hospital rule correctly. That's it. Okay.
yes. Okay.
Now we will try to solve for one sum. Which one? Okay. This might be interesting. Limit x tends to infinity 2x square plus 3 by 3x square plus 2 whole to the power x. Can you try to solve for this?
I will try.
Yeah. Sir, you can also try.
One.
Uh, how did we arrive to that conclusion?
First two terms will be 0. 3 by 2 is 1.5. 1.5 to the power of 0.
Huh? Uh, so we are applying limit to infinity here. So let us wait for Dhyan. After that, I will answer. Dhyan, okay. Dhyan, I will slowly start here, solving here. You can look into the screen. Okay,
Okay.
now before solving, can I simplify this equation? What I will do is I will multiply x square to both of this. So if I multiply and divide by x square, what will happen? 2x square plus 3 is multiplied by x square by x square. Okay, just look into the equation what I'm doing here. I'm just trying to prevent from getting infinity again with the same error. Okay, 2
Okay.
into, just I'm multiplying x square by x square. So now what will happen? This will cancel this, right? But here it will come back here now. So
Yeah.
eventually what I will get is 2 plus
3 by x.
3 by x square whole
X
into
square.
x square by yes, by 3
3 plus.
plus 2x square. Okay,
Yeah.
into x square. Okay, I'll cancel this out. So eventually what I will get is limit x tends to infinity 2 plus 3 by x square whole by 3 plus 2 by x square whole to the power x. Right? We did not do we did not apply anything additional here. We just try simplifying the equation. Now imagine if I limit into infinity, what will happen here? Any number by infinity is 0. So it will be 2 by 3 to the power infinity. Okay, right? I
Yes.
just applied infinity and I did not apply L'Hospital rule here. I'm just trying to solve it without the rule. So I get 2 by 3 to the power infinity. Do you know that there is this condition? If x is greater than 1 and you do x to the power infinity, we'll always get infinity. If you do x equal to 1, that is x to the power infinity will always lead to 1. And if x is like in between 0 to 1, will always, if I do the x to infinity, it will always lead to 0. Okay, and at last x equal to 0, then x to the power infinity is 0. So where does this lie? 3 by 2, sorry, 2 by 3. 2 by 3, what is 2 by 3? What is 2 by 3? Come
Less
on.
than 1.
It is 0.6666 something. So to the power infinity, what would be my result then here? It would be 0. Okay.
Yes.
And I was able to compute the answer. I am not getting not defined here. Okay, not every time it is necessary that you apply the rule. Sometimes you can solve by this method by just manually applying by simplifying the equation basically. Okay, I
Yeah.
hope it is clear.
Yeah, it's clear.
Now let us try for something much simpler. Okay.
Okay.
So I want you to try for limit x tends to pi by 2 secant x minus tan x. Can we do this? So basically, let me solve this. What happens if I apply pi by 2 here directly? Secant pi by 2 minus tan pi by 2 would lead to, what would it lead to?
Not defined.
So in order to solve this, let us apply first derivative once. So 1 by cos x minus sin x by cos x. I'm just trying to simplify it as much as possible. So now once I do this, now you can see both denominators are same. So it will be 1 minus sin x by cos x, right?
Yeah.
Now if I apply derivative, what will happen? Now if I apply derivative, it will become minus sin will become minus cos x. This one will become 0 anyways. Cos x will become sin x, minus sin x basically, sin x. 0, 0 cancels. Now if I apply pi by 2, what will be the result? What is sin pi by 2?
Sin by beta is 1.
What is cos pi by 2?
0.
You see, okay. Now in the first step we use the rule. Second, it does simplified, and in the third example we combined both, right? Okay.
Yeah.
This was basically introduction to calculus. There are other things to learn here. That would be continuity, that we can touch upon continuity once again. Apart from that, there are some optimizations and Taylor series that helps us solve the equation much more easier. So we can learn about them in some other session, or you will be eventually learning them in your engineering career. So with this, I would like to conclude today's session. I'm open for doubt for the next 5 minutes.
Oh,
Sir. Sir is not available here. Do you have any doubt, Dhyan?
mm, no.
Okay. Yeah, I think this was it for today's session. Okay. Thank you.
Thank you. Thank you, sir.